NVIDIA's story is a compelling chronicle of technical innovation and strategic adaptation, tracing its roots from a humble graphics company to the indispensable leader of the global artificial intelligence AI revolution. Founded in 1993 by three highly motivated engineers, Jensen Huang, Chris Malachowsky, and Curtis Priem, the company's initial mission was singularly focused to bring realistic, high-performance 3D graphics to the burgeoning personal computer market. The foundational breakthrough came in 1999 with the introduction of the GeForce 256. This product was revolutionary not just for its performance, but because NVIDIA defined it as the Graphics Processing Unit, GPU. The GPU's architecture was inherently different from a standard CPU. It was designed with thousands of small cores capable of performing massive parallel processing, conducting countless calculations simultaneously. This ability was perfectly suited for the complex task of rendering 3D graphics, quickly establishing the GeForce line as the dominant force in high-end PC gaming. While gaming provided the initial success and revenue stream, the true game-changer for the company lay in the GPU's unique internal structure. The crucial pivot began in the mid-2000s when researchers in fields like physics and bioinformatics recognized that the parallel processing capabilities of the GPU could accelerate general-purpose computational tasks far beyond graphics. To capitalize on this external interest, NVIDIA developed and released CUDA Compute, Unified Device Architecture, in 2006. CUDA was a masterstroke, a software layer and programming platform that allowed scientists and engineers to easily harness the GPU's power for complex computations. This move transformed the GPU from a specialized graphics chip into a versatile, high-speed parallel processor, making NVIDIA an active participant in high-performance computing. The development of CUDA positioned NVIDIA perfectly for the explosion of deep learning and artificial intelligence, beginning in the 2010 seconds. Training the sophisticated neural networks that power modern AI requires processing colossal amounts of data and performing trillions of simple calculations simultaneously. The GPU, enabled by the CUDA ecosystem, was the only viable and scalable hardware available for this task. As a result, NVIDIA's GPUs became the foundational hardware for every major AI research initiative, corporate data center, and cloud provider globally. Today, its specialized chips, such as the H100 Tensor Core GPUs, are the undisputed engine driving advanced generative AI and large language models. These components are frequently referred to as AI factories, underscoring their critical role as the infrastructure of the new digital economy. NVIDIA, under Jensen Huang's sustained leadership, has successfully navigated this evolution. It is no longer just a hardware vendor, but a full-stack platform company whose technology is accelerating every frontier of modern computing, from robotics and autonomous vehicles, NVIDIA Drive, to complex industrial simulations, Omniverse, solidifying its position at the apex of the global technology sector.